probably going to get about halfway through today's lesson. We'll finish the rest of it next class. First of all, we've been talking about G's, about G-forces. Last class, we looked at Colonel Stapp, who I think had handled, I think it was 45 Gs or somewhere around there. As far as I know, I did some Googling. This is the record, the documented record for surviving the biggest number of Gs. So in 1977, in Northamptonshire, England, David Purley's race car crashed. Oh, if you crash, what's V final? In any crash, okay. And his speed dropped from 174 kilometers per hour, we'll have to do a conversion, in 0.66 meters. He had 29 fractures, 3 dislocations, 6 heart stoppages, but he did survive. How many Gs did he experience? When I'm saying how many Gs, what I'm really asking you to find. So let's write down A equals question mark. And then to change it into Gs, we'll divide our answer by 9.8. Well, I know this. I guess they gave me D is 0.66, yes? And V initial was 174 kilometers per hour. How do I convert that? I think divide, isn't it? I hope it's divide. So I'm going to go 100, this one won't work out evenly because I'm using actual numbers from real life, not numbers that I've made up. 48.333. I'm going to write 48.3, but Jess, I'll just keep this on my calculator. I'm going to use my answer button. 48.3. All right, which equation can I use to find acceleration? Oh yeah, you might want your purple sheet out. And your calculator. Which equation can I use to find the acceleration here? Ooh, I like that. Plus 2AD. And Andy, it looks like I'm trying to get the A by itself. So I think what I would do is I would minus this over to that side. So first of all, the VF squared is going to drop down like a domino. Let me do that, right? There's the VF squared. You know what, Mr. Dewick? You're going to have to move sideways. That's not enough room. There's the VF squared drops down like a domino. I would minus the VI squared over, yes? And what that would leave me with, don't write this down, don't write this down. The 2AD would drop down, except Andy, what am I trying to get by itself? How can I move the 2 and the D over? Divide, you say? So if I hear you correctly, what you're really saying is that what you're saying? All right, let's plug and chug. A equals VF 0 squared minus VI. I'm going to write 48.3 squared, but I'll use my answer button there just because I'm a nerd. All over 2 times 0.66. By the way, is this guy speeding up or slowing down? It's pretty obvious. Is this guy speeding up or slowing down? Am I expecting a positive acceleration or a negative acceleration? If I get a negative answer, I'll smile and say I probably got it set up right. Is this a fraction, Alicia? Is there more than one number on the top? Brackets. Is there more than one number on? Okay, so I'm going to go bracket. 0 squared. I probably didn't need to type the 0 squared, but just if there was a number there, that's where it would go, so I'll show it to you. Minus, answer button squared. Wasn't that clever? Wasn't that clever? Divided by bracket 2 times 0.66. So in terms of meters per second squared, he experienced negative 1,769.8, which is high. How do I convert that to G's? This is the record, as far as we know, for surviving that we've been able to document. He pulled off 180 Gs. Again, that's the equivalent of having 180 people dogpile and a half. Okay, fine. 180.6. I saw Sarah looking at me. It's not 180. Round off properly. You're right, Sarah. 181 people dogpiling on him. But he survived. I'm going to go negative 181 Gs. I don't think it's been broken. This is from about 4 years ago when I did the Google search, and I haven't heard of anyone surviving a massive crash since then. So it's possible, Matt, somebody did survive more, but there was no cameras to document the feat. I don't, Maybe there's a car accident victim who did survive more, but cameras didn't catch it. Anyways, don't do that. Free fall. When an object is falling through the air, we say it is in, the word we use is free fall. In free fall, near the Earth, the acceleration is always what? We mentioned this in my rant before the lesson. Negative. Okay, I'm going to even write g equals negative 9.8 meters per second squared. I was going to say you'll probably memorize. Sheldon, you'll memorize that one. You'll get sick of looking it up. Okay? So from now on, if an object is in free fall, then what that means is I'm not going to tell you A. I'm going to assume you clue in that you can fill in A. So you know how I list my data, A is going to be negative 9.8. Of course, that changes in other places, like the moon. If you want, on the moon, G is about negative 1.6, or in outer space, no gravity, but we're going to be on the Earth. So, what can we now solve? A cannonball is dropped from a cliff. This is similar physics to you guys dropping your erasers from the railing last day, okay? So a cannonball, underline the word dropped. This is one of those physics trigger words, because if I drop something, what's VI always if I drop something? So we always know that VI is 0 if we drop something. Now, I won't always drop it. Sometimes I'll throw it, but then it's pretty obvious because it gives me an initial velocity in the question. Hits the ground 10.6 seconds later. A says, how high is the cliff? What is A asking me to find? I know it says how high. In terms of the variables that we've been using here, what's it asking me to find? D. And I know VI is 0. Prith, are we in free fall?
Say yes.
Then I know A. What's A? Negative 9.8. What else did they tell me? It looks like they gave me a time. Okay? Now, a common mistake kids will say, and this is wrong, Mr. Duick, I know V final. 0. No. V final is how fast you're going when you hit the ground. And I assure you, when you hit the ground, you're not going 0, otherwise it wouldn't hurt. After you hit the ground, sure, 0. But don't be telling me that V final is 0 in free fall. That would really dramatically change. Parachutes wouldn't be necessary. Okay? So, what equation has D, VI, A, and T in it? Which one, Court? Hey, Courtney, are any of these 0? When you're dropping something, this is going to be a special subcase of our 4 equations. And now you're also learning why I said don't memorize, because there's subcases and there's sub-subcase and special cases. Don't memorize them all. But when you're dropping something, VI is going to be 0. What that means, Courtney, is I can cross out that whole thing, because 0 times T, 0 times anything is 0. So I actually just get D equals a half AT squared. Courtney, what did you say we were trying to find? Oh, the D's by itself already. That's convenient. So it's going to be 0.5, negative 9.8, 10.6 squared. Try this on your calculator. You're going to get something a little weird, but then when we think about it, it will make sense. What'd you get on your calculator that you all have, that you're trying, that would go way faster if people typed faster, because otherwise this just means you end up with more homework because I'm waiting and stalling? What'd you get? Negative 551. Let's go negative 551. Let's write that down. Why am I getting negative? What's that telling me? Well, we're into the world of vectors. Which way did you let down negative be, up or down? Did you end up above or below from where you started when you dropped something off a cliff? Below. The universe is saying, oh, and by the way, hello, McFly, you ended up below from where we started, which I kind of like that. Okay. Now, in English, do we say a cliff is negative 551 meters high? So, for what it's worth, you can say this. Technically, boy, did I spell that wrong? I'm missing the N. Technically, height is a scalar, 551 meters. I'm not going to be fussy, Ryan. If you give me a negative displacement as your cliff height, I'll clue in what you mean. Okay. B. What's B asking me to find? I know it says impact velocity, but in terms of the variables that we've been talking about, what's B asking me to find? VF. Sarah, have we turned the page or anything like that? I'm not going to bother redeficking. I have it all there. So I'm looking for an equation. Has to have VF in it. And then VIAT. Okay, if I need to use D, I can, but I'd prefer not to. Which equation has VF in it? VIA and T and maybe a D, but prefer not to. Which one, Matt? Are you telling me VF's already by itself too? Oh, that's nice. Oh, hey Matt, why can I do that? Okay. What's A, Matt? And T is 10.6. I'll call it negative 104. Why negative? Because when I hit the ground, what direction am I traveling? Yeah. Okay, hashtag nerd trivia. Any of you ever stood on a cliff somewhere and dropped rocks? Okay, so next time you're doing that, if you happen to have your phone, if you time how long it takes to hit the ground, negative 9.8 is really close to what nice round number? 10. Take the time, times it by 10. That's how fast you hit the ground at. In case you're a nerd and kind of wonder these things. Or if, like me, you're standing in line at Playland and you see a Freefall ride and you're kind of wondering how fast. Okay. No? I think it makes it funner. C. What's C asking me to find? Okay, and a different VF. So I'm going to go like this. What's changed? What other condition did I give you? I said find the velocity of the cannonball after what? So you know what? I'm going to redefic that part. But Alex, have we turned the page? So VI is still 0. I can still, just don't use the 10.6 for the time. Oh, certainly A is, you know what? I'm not going to rewrite. A is negative 9.8. I think I can do exactly the same thing, Alicia, we just did. I think it's going to be VF equals VI plus AT, except I'm going to use 3.6 seconds right there. Okay. Yay. It's going to be negative 9.8 times 3.6. Negative 35.3. Technically, I should go to 2 sig figs, but whatever. Negative, is that right? Negative 35.3? Negative 35.3 meters per second. So I can tell you how fast an object, if we dropped it, Courtney, is traveling at any time in its path. What else? Oh, how far has the ball fallen after 3.6 seconds? What's this question asking me to find? Okay. Time again is still 3.6. VI is still 0. A is still negative 9.8. Which equation can I go with here? You know, so I've turned the page, so I'm going to quickly redefic. So I'm going to go negative 9.8. I think you guys are still on the same page, yeah? It's up to you. That's an A. D equals VI, I think Courtney's equation, yeah? D equals VIT plus a half AT squared. Conveniently, VI is 0. So it's going to be 0.5, negative 9.8, 3.6 squared. 0.5, negative 9.8, 3.6 squared. Negative 63.5 meters. It's 63.5 meters below from where I dropped it. Or negative 63.5 meters. So, Sheldon, if we drop something VI 0, that's boring. I mean, drop, okay, fine. But usually, and I don't know about you, but I've stood on cliffs and thrown rocks, making sure nobody's down below. But especially when you're in the Fraser Canyon, if you pull over on the Trans-Canada, you try and get them into the Fraser River, it's lots of fun. Usually you chuck stuff. So let's suppose you're standing on the edge of a cliff, like this, don't write this down, and you're going to throw a ball straight up, and it's going to fall down just past the cliff all the way down to the ground. Okay. A ball is thrown straight up with a... actually, I think this person is standing on the ground. Sorry, we're going to do a cliff later. Ball is thrown straight up with a velocity of 29 meters per second. A. How long does it take for the ball to reach its maximum height? I like this question. I like this question. I like this question. What's this question asking me to find? Okay. What else do I know? Sorry? It's slowing down? Okay, more specific. What's the acceleration? Oh, we'll get to that, but what's the acceleration? Yes? Okay, it's in free fall. I don't care if it's going up. I'm telling you, gravity is still slowing it down. What's that 29? That's VI, right? This time because we're not dropping it. And now I'm going to come back to Andy, because Andy had that aha. Andy, when you throw something straight up at the top for a split second, how fast is it traveling? Right? Right? I'm looking for an equation that has T, A, VF, and VI in it. Which one, Jess? And I guess no D. I agree. You think you could get the T by itself in your head? More specific, can you just rattle it off to me? Can you say T equals and tell me the equation? Remember how foreign that seemed about a week and a half ago? There you go. Now it's plug and chug. By the way, time, scalar or vector? Time, scalar or vector? Time, scalar or vector?
Scalar.
So am I expecting a negative or a positive answer for time? If I ever get a negative time, I'm going to freak. I've done something wrong. I'm sorry, you're not traveling back in time. You're not getting a Nobel Prize. I'm sorry, you've made a mistake. 0 minus 29. See, this is nice because the top is negative, but so is the bottom. I get a negative divided by a negative. There's my scalar time. 0 take away 29 divided by negative 9.8. 2.96. I'm going to 3 sig figs pretty consistently, I think. 2.96 seconds. By the way, that's how long it took to go up. How long would it take to come back down? 2.96 seconds. Oh, so you can even get the total time of flight. Now, that's only because we're starting on the ground and ending on the ground. If you're on a cliff, it's going to fall down for longer than it went up, and so that's going to change things. Oh, what's the maximum height reached by the ball? Okay. I guess this is asking me to find... Have we turned the page? No, you say? I'm not going to re-defic everything. I'll scroll up a tiny bit so I can... I'm looking for an equation. It has to have a D in it. And then It'd be nice if I can use A, VI, and VF. I'll use a T if I have to, but if I can find it using the stuff that they gave me, I'm happier. What's an equation that I could use here? You see it, Rye? Which one? Can you get the D by itself in your head? I agree. Oh, you go. You had a little nerdy adrenaline rush there? Like, look what I did, mummy. Yeah. Okay. Rye, what's VF? 0. Oh, I like that. I can do math with zeros pretty good. Squared, don't forget the squareds. Minus, what's VI? Squared, don't forget the squareds. All over 2 times, negative 9.8. By the way, are you already starting to memorize that negative 9.8? We're going to use it in every question, so it's worth doing. Do y'all get... did we end up above or below from where we started, Ryan? If you throw something up in the air, is it above or below you? Am I expecting a positive displacement or a negative displacement? Did I get a positive answer? So I smile here, because this is not like we were dropping it off a cliff where we got a negative answer. I smile here and said, okay, the universe is telling me I'm doing this okay. 42.9 meters, yes? That's a pretty good throw. By the way, let's suppose this was a test question. Hint, 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 hint. I like this question, I like this question, I like this question. And you finished the test early. What I would do is I would really quickly go like this. Because that's another way to find distance, except that's going to use my time answer from part A. But if I get the same answer as I did doing it your way, then I know A is right. In other words, I would very quickly go, okay, what was VI? 29 times 2.96 plus a half times negative 9.8 times 2.96 squared. Did I also get 42.9? You know what? That can't be a fluke. A is right as well. Yay, I know they're both correct. Because you now have multiple ways, often, of getting the same answer. I almost always try and do it using the data that they gave me. But then, Courtney, if I got extra time, I'll go back and try it the other way using the data that I calculated. If I get the same answer, yay. If I don't, I've probably made a mistake somewhere. Is that okay? So I can't say there's a built-in error check, but Haley, I can say there is an error check. What's the impact velocity of the ball just before it hits the ground? Don't say 0, because it's not. This is far easier than you realize. In fact, this question here is so easy that it's tough. Really? Yeah. I kid you not. Cohen, are we starting on the ground? Say yes. Are we ending back on the ground? In other words, is there a cliff in this question anywhere? No? Then you know what we can say? We can say this. Can you finish the last word for me? What goes up must come. Anybody want to guess what V final is? 0. Not 0. That's after it hit the ground. Don't ever tell me that. If V final was 0 when you hit the ground, we wouldn't need parachutes. Hey, that sounds like a rant I've already done, but do you see it's a common mistake kids make? That's after it hits the ground. And I said impact velocity. Anybody else want to try? Yeah. Yeah. Yep. Comes back down and it hits the ground at exactly the same speed as it left. I said speed. Same velocity, opposite velocity, but same magnitude. That can be really handy. Now, again, if we're on a cliff, Lindsay, that's not going to work. How long is the ball in the air for? What's this question asking me to find? There's 2 ways to do this. So I want you to draw a little line about 2/3 of the way over. The second way is to use something we've already calculated. We already know that the time to go up, can I call that T up, was it 2.96 seconds? I think it was, yes? So t total is going to be 2.96 times 2. You know why? Because what goes up must come, and you're starting and ending on the same height. So I know that's the answer. I'm going to quickly crunch it. 5.92 seconds. What if I hadn't done the first calculation already? Connor, what if I hadn't done part A yet? Okay. That's why I left some room over here, Lydia. Just because if I'm lazy, if I haven't done part A, why would I do part A to find this if I can do it all in one fell swoop? Well, I know this. I know this. Prith, what else do I know? What did you just tell me on the previous question? Hey, I'll bet you there's an equation that has time, A, VI, and VF in it. There is. I think it was Jessica who said it's the VF equals VI plus AT. And I said, hey, Jess, can you get the T by itself? And she smiled with a little twinkle nerdy in her eye. And she said, well, yes, I can. Jess, what is the equation that has VI, VF, A, and T? And VF equals VI plus AT? Yeah? Get the T by itself? I think the VF drops down like a domino. Yes? Minus VI over A. That's the equation you gave us. Yeah, Jess? You're looking so awake. Okay. Oh, we can plug and chug. Negative 29, that's V final, minus 29. Mr. Duick, doesn't the top work out to 0? No, 29 take away 29 would be 0. Negative 29 take away 29 ain't going to be 0. I'm expecting 5.92. Did I get 5.92? Yay! Some rounding along the way, but yeah. Okay. E. What is the displacement of the ball once it hits the ground? Now, if I had asked what distance did the ball travel, how far up did the ball go? Can you turn? I forget. What was our height? 40 something? What was it? 42.9? So the total distance would be 42.9 up plus 42.9 down is 85, something in the 80s. It's not what I asked. I said, what's the displacement? It's a trick question. What's the displacement? 0. Because how high was I when I started? 0. And how high did I finish? 0. What's my change in position? Nothing. If you want to, you can put units. Okay. So free fall. We know the acceleration. Dropped, VI is 0. If you're not dropped, I'll give you an initial velocity. Example 4. Now let's stand on a cliff and throw something. So ball is thrown straight up from a cliff at 12.5 meters per second. It hits the ground at the base of the cliff after 8.85 seconds. Okay. Ty, what's A asking me to find? Let's list our data. Are we throwing something? Is it in the air? Are we in free fall? I know A. Ty, what else do I know? 12.5. What else do I know? $8.85. Trevor, do I know V final? No, because when I hit the ground, is the answer 0? No. Right? Right. Okay. Oh, hey, this isn't bad. I can plug and chug. I think there is an equation that has D, A, VI, and T. And not only that, I think the D is already by itself, isn't it? Matt's nodding. I think it's this puppy here. Now, really, I'm being sloppy with my notation. This equation gives me the displacement. Am I ending up above or below from where I started if I'm throwing it off of a cliff? I'm anticipating a negative answer here. Yeah? It's going to be 12.5, 8.85, plus 0.5, negative 9.8, 8.85 squared. How high is the cliff? $12.5 times 8.85 plus a half times negative 9.8 times 8.85 squared. You get negative 273 meters. 0.1, that there. It's a high cliff. It's about what? Divide by, well, yeah, it's about 90 stories. That's a pretty high cliff. What's the maximum height of the ball? What's this question asking me to find? D. Didn't we just find D? Okay, we found D to the bottom. Plug and chug. Now we want to find D to the top. To the top. You know what, Andy? I think we're going to use the same trick that you gave us. I think we're going to say this. And just to distinguish, I'll call it D top. There's my high-tech notation. I'll go question mark. I certainly, Trevor, know this. Right? I certainly know VI. Right? What distance are we finding? The distance to the, I'm looking for a word that begins with letter T and has 3 letters. Looking for a word that begins with letter T and has 3 letters. Distance to the top. What else do I know at the very, 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 very top for a split second? And this is worth filing away in your brain.
0.
What's 0?
The max height.
The max height isn't
None
0.
of the velocity.
I don't know which velocity. Okay.
Yeah.
We'll try this again. What? VF is 0. Okay. By the way, trust me, leave a little bit of room to the right there. You're going to need it. I'm looking for an equation that has A, D, VI, and VF in it. No T. Because, by the way, this time, that 8.85, that's the time to go to the top and fall all the way back down. So that doesn't tell me how long it took to, I can't use that T. You know what, Ryan? I think this is your equation again, isn't it? It's the VF squared equals VI squared plus 2AD. Yeah? Although you argued it was D equals, you said VF squared minus VI squared all over 2A. 0 squared minus 12.5 squared all over 2 times negative 9.8. 0 squared minus 12.5 squared all over 2 times negative 9.8. $7.97 blah, 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 that. I'll write 7.97. And this is wrong. This is wrong. I'll pause and see if anybody can spot why this is wrong, how this question is different from the previous one that we did. Connor. We're standing on cliff. What we have just found is how high it went above the thrower. 7.97 meters. But where was this thrower? On the ground? No. On a cliff? Ah! That's why I said leave some space. So the height is going to be the cliff plus the throw, if you want to write that in English so you know what the heck our argument is. It's going to be, how high was the cliff, Connor? Ah! And I'll call it positive now, because I'm measuring everything from the ground up. Plus 7.97. So I'm going to add 273 to this. I'll call it 281. That's how high off the ground it was. Is that okay? I like that question. I like that question. I like that. Hey, what's C asking me to find? VF? Okay. I know A is negative 9.8. What else do I know? T is, what was T? 8.85, was it? Whew. VI, 12.5? Okay. By the way, when we hit the ground, are we traveling up or traveling down? Am I expecting a negative velocity or a positive velocity? If I get a positive answer, I'll freak. I've done something wrong. Things don't fall up. Oh, this is nice. I think I can use VF equals VI plus AT, can I not? And VF's already by itself. Nice. 12.5 plus negative 9.8 times 8.85. Hits the ground at negative 74.2 meters per second. Meters per second. Units, meters per second. Is that okay? Pause here. Can you get out this thing? Okay. Now, what we were doing is yesterday, last class, is collecting the data required. We're hoping to find or to calculate the acceleration. We're going to be off because your stopwatch human reaction time is bad. Now, we did say the distance that we were dropping it was negative 4.5 meters. Why negative? Because we were ending up below from where we started from, right? So let me walk you through what you're going to do here. First thing you want to do is get an average free fall time. So you got 10 times here. Yes? Add them all up. First of all, look, if there's any that seem way off, cross them out and don't use them. If there's a piece of data that looks garbagey, oh, all my times are like 0.9, 0.9, 0.9, 3.6, don't use the 3.6. That's acceptable research. What you're going to do is you're going to add up all the times and then divide by how many there are. For most of you, it'll be add them up and divide by 10, unless you chucked a value. Okay? And that's going to give, displacement, negative 4.5 on the next page. And there is where your average free fall time is going to go. Okay? Then, I wrote here acceleration calculations. What am I asking you to find? I'm asking you to find A. In fact, if you want, instead of A, you can put a little, I'm asking you to find G, which I'm going to treat like an A. Is that okay, Court? What else do I know? Well, I know this. Right, Sheldon? Oh, did we drop these objects? Anytime I drop something, what else do I automatically know? It's negative 9.8, but we're trying to calculate the acceleration, so I'm not going to put that in. What else did I say? When we drop an object, that implies something. What? Let's write down VI equals 0. And then T equals whatever you guys got for your time value. That's going to go there. And remember, G is A. You're going to be looking for an equation that has A, D, V, and T in it. And then you're going to try and get the A by itself. And you're going to calculate it. Oh, and by the way, one of these is 0, which I think is going to make your equation a little prettier somewhere along the way. Okay? So you're going to try and calculate your theoretical value for G. You should get a negative answer, and hopefully it'll be close to 9.8, but I've seen everything from like -5 to -15 because people are lousy with the stopwatch. Okay? You okay with that, Alex? Then, conclusion. Number 1, you're going to write what value did you get for the acceleration due to gravity. That's where you're going to put your final data. The acceleration due to gravity is, it's actually negative 9.807, which is negative 9.81. We're going to use 9.8 all year long. Did you get this value exactly? If not, what are some reasons why you may have not got that value? The big one is going to be human reaction time, but you may have noticed some other things as well. Then we're going to do this percentage error thing. Let me walk you through this. Here's what you're going to do. You're going to take the value that you calculated, the answer that you got right here. You're going to subtract negative 9.81, the actual value, and divide by, should be a negative there, negative 9.81. Is that a fraction? Yes. Is there more than one thing on the top? Yes. So what will you remember on the top? And then you're going to take that answer. Have you guys in Math 11 now learned what do these vertical lines mean? Have you guys seen these yet? Absolute value yet? Okay. These vertical lines mean if you get a negative answer, ignore the negative, make it positive. If it is positive, leave it positive. Times 100%, and that's going to give you your percentage error. Let me just walk you through it. For example, let's suppose I ended up getting an answer of 8.8. I would go like this. Negative 8.8 minus negative 9.8, close bracket, divided by negative 9.8. I'm going to ignore the negative, times 100%. I have 10.2% error. Your value minus the actual value, divided by the actual value, and then to change it into a percentage times 100. This is sort of like calculating your average on a test, except we're calculating the average that you're off by. Okay? Then, using the correct value of negative 9.8 for G, calculate V final when your object hit the ground. It's not 0. Oh, sorry, that slipped out. So that's your first bit of homework today. Second bit of homework today, I have a take-home quiz.